So the particle is projected at 14 root 3, like so. And there is two, what we call that, alpha. And therefore it's going 14 root 3 cos alpha and 14 root 3 sine alpha. I'm going to set up my 4 equations, Vx. Now, what we know is that this point here is the point 60 and minus 60. Your Sx value equals 60 and your Sy value equals minus 60. And the reason for that is it drops 60 below where you started from. So phi x equals 14 root 3 cos alpha, stuck in that position. Phi y is 14 root 3 sine alpha minus gt. I don't think it says in terms of g, so I'll just call it 9.8t. And then Sx will be 14 root 3 t cos alpha. And then finally Sy is 14 root 3 sine alpha minus a half gt squared, so minus 4.9 t squared. Now, we know the deal with Sx and Sy, and we're very aware that it could be done either using the blue path, which is a higher trajectory, or the red part, which is a lower trajectory. So we're going to get these two bottom equations. One of them's going to equal 60, and the other one's going to equal minus 60. Now, I'm going to take this top one. I'm going to use this yellow one here. I'm going to isolate t. So t, which is your time of flight, will be 60 divided by 14 root 3 cos alpha. 60 divided by 14 root 3 is 10 root 3 over 7. Okay, t equals 10 root 3. Now, we have 10 root 3. So that's, look at the board, I want to look at the screen. All right, 10 root 3 all over 7. All right, we're going to insert that into the Sy formula. And for Sy, what we're going to get is Sy equals 14 root 3. Oh, I forgot the t there, didn't I? So 14 root 3 multiplied by 10 root 3 all over 7 cos alpha sine alpha minus 4.9, which is still 4.9, and then we're going to do t squared. And what's t squared, lads? Going to square this out. So it's this thing squared, 300 over 49. And lucky for me, I'm going to multiply that by 4.9. And there's a cos squared on the bottom as well. Just gotta grab all this. Okay. And 300 over cos squared alpha. Okay, you guys. And who got that? More or less. Now, what happens to the 4.9 and the 49? I think we're going to interact them together, and what will happen? 4.9 multiplied by 300 over 49. 30. Now, what was that trick we said when you see cos squared alpha on the bottom? What can you turn into? 1 plus tan squared alpha, and just get rid of the cos squared alpha then, yeah? And what happens over here? We're going to have to multiply 14 root 3. We're going to multiply that by 10 root 3. And then we're going to divide all of that by 7. And we're going to get 60. What's sine alpha over cos alpha? Tan alpha. And what does xy turn into? Minus 60. Okay. Multiply in. 60 tan alpha minus 60. Now what happens next? Yeah, you can do the minus b, all right. So 60 alpha. What's plus 30, is it? Is that right? I have a feeling this might be a perfect square. Just one answer, is it? Divide both sides by 30. Who got an answer of tan alpha equals 1? Anybody get that? You did? You didn't. My mistake is located here. That's meant to be. Ever see that? Now, if I divide across by minus 30, what would that change everything into? What's that change this into? The whole system? Divide across by minus? Well, minus 2 times alpha minus 1. Now we're going to do the minus b formula. Would you do the minus b formula for me and tell me what the 2 times alphas will be? So it's going to be 2 plus square root. So it's going to be 2 squared is 4 minus 4 minus 1 over. We got 1 plus root 2? Yeah. And 1 plus root 2, and the other one has to be 1 minus root 2. Yeah. Does it ask for the angle? Wants the angle, so we have to tan inverse both of them. Shift tan inverse 2. Oh, I'm in shift setup degrees. Who got 67.5? The other one. Minus 22.5. Now you guys aren't equipped to deal with this just yet. What? Yeah, I think that's what that would mean. Sort of straight underneath, doesn't it? Angle it downwards. Yeah, that's the only thing that makes sense, isn't it? Who got that as well? Minus 22.5? Means you angled it down. Now we need the 2 times of flight, okay? So here's what we're going to do. Does everybody see the time? Does everybody see this formula here? What I want you to do is I want you to, first of all, do 7 cos 67.5. And then do the other one as 10 root 3. Which one do you think is going to be faster? The one where you just angle it down and throw it at it. Okay? And put the 2 of them into your calculator and see what we get. Ten root 3. The first time we have to do a negative angle like that, wasn't it? 7 cos. I'm expecting this one to be fast. 2.68 seconds. And I'm expecting the other one to be slower because you lob it up and it falls down. So 67.5. 6.47, yeah. Anybody beat me to it?